This video is to help you learn to get a better understanding of using a random number table in order to carry out an experiment, which will give you the experimental probability of an event happening. So this is a question actually off last year's final. So this is the question I did not use this year. So we're going to be trying to find children of all the same gender in a family of 4. Okay, so we know that the chance of a boy versus a girl is 50-50. Okay, so half of our digits, we've got digits 0 through 9, half have to represent boys, half have to represent girls. So one possible way this could be done is evens and odds, right? And so it's totally up to you. You just have to decide before the experiment. Okay, so we could do evens and odds. I think I'm going to do boy 0 to 4 and then girl 5 to 9. I think I'll do that for my experiment. Okay, so the first thing you'll have to do is describe like how you are going to select digits to represent different outcomes. Okay, then I have families of 4 and yet I have clusters of 5. So there's 2 different things you could do. One thing you could do is you could say, well, I'll make this a cluster of 4, then I'll take this number and make this a cluster of 4, and then this a cluster of 4. And if you know your least common multiples, by the time you have 12 numbers, you will have, you will be back to, did I get that right? My pen is so thick. 1, 2. Oh, I covered one up though. You can't see it because of my pen. But you will eventually get back to where you're at an even point. I think it's easier. You know, I don't usually do that, but that's a possibility. So again, you decide how you want to do your experiment. I think it's better to just, you know, if there's 4 numbers, or if we're talking about a family of 3 or a family of 4, you'd cross out the last number or the first number. You just decide first. If it were a family of 3, cross out the last 2 numbers. Okay, so I'm going to cross all of these out. And so then what I am looking for, so in each cluster, so I've got 20 here. In each cluster, I am looking for there to be either 4 low numbers or 4 high numbers. Okay, so 4, 0 through 4s would represent 4 boys, and 4 girls. Like I'm already starting to look, and I see right here as I'm crossing off, right here, this would be a success, right? That would be 4 girls. Okay, so these are all girls according to what I decided to do. All right, I'm going backwards. I don't know why I'm going backwards. I just am. Like if you had decided to do evens for boys or girls, this would be a success right here, right? If you had done evens, because there's 4 evens in a row. So I need all either low numbers or all high numbers. And there's only a 1 in 8, which is a 0.125 chance theoretically. So I don't expect for this to happen a ton. I think it should happen. Well, honestly, if it only happens 1 time out of 20, well, that's 0.05. That I would expect it maybe to happen like 1 more. Although I don't think it is. Actually, it never happens again. I wonder if I had done evens or evens and odds, if I would have gotten. So I got a 1 out of 20, which is 5%. Okay, which is 0.05. So, you know, that's about half of that. I would have expected, you know, to have had 2 out of 20. That would have made it closer to the theoretical probability, but that's part of why we should do more than 20 trials. 20 trials is really not that many. So let's say Let me see, I'm going to change to green. If you had done evens and odds, this would have been a success. Just seeing if anything else would have been a success. Because I would expect the probability to be 2. If we had 2 out of 20, that would be pretty close to the experimental. I'm having combinations of evens and odds here. Yes, I am. Oh, all right. Even if you did evens and odds, you'd still get 1 out of 20. So let's come down here and take a look at this scenario. Okay, so we've got rainy season on an island, and any given day you've got 70% chance of rain. Okay, which means you have to assign your digits, 70% of your digits, to represent rain. Okay, so I'm going to go ahead and do 0 to 7, rain. Okay, and then no rain can be, wait a minute, 6, 8. Oh my gosh, I skipped the number 6. Wow, it's been a long couple days. I just graded, bear with me, I just graded 100 papers in 48 hours, so bear with me. I'm like, how am I missing a digit? Okay, so then this is no rain. Okay, so I want to find the probability that it will rain at least 4 out of the next 5 days. So at most, I can only have 1, 7, 8, or 9. Like this would be a success, right? Because it's 4 rains in a row, then the last day it doesn't rain. Okay, so I need at most 1. So here's 3 days of no rain. Here's 2 days of no rain. Here we go. This is all 5 rainy days. Okay, there's 2 days of no rain, 3 days of no rain, all 5 rainy days, 2 days of no rain, 3 days of no rain, 5 rainy days, 2 days of no rain. Again, here's 5 rainy days in a row. This is another 5 rainy days in a row. All right, this is a success. There's 1 day of no rain out of 5. Okay, so that 9 is the 1 day representing no rain. Okay, now here we've got 3 days of no rain in 5 days. Here we've got 3 days of no rain in 5 days. Here we've got 2 days of no rain in the 5. This would be a success. So this is 1 day with no rain, and then it rains the next 4. 2 days of no rain, all 5 days of rain. Okay, so again, there were 20 here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 9 out of 20. And when I want to change that to a percent, I can use my calculator and divide. Or I could leave it as, I could leave it as 9 over 20. That's a probability. Or if I wanted to change it to a percent, I can scale up by 5, right? And so you've got a 45% chance that it will rain at least 4 out of 5 days, right? Not my ideal sounding kind of weather. Okay, so I hope this helped you understand simulations and random number tables a little better.